Today we will be discussing logarithms, an important Algebra 2 and Precalculus topic. But before, let's review exponentation, so that we can better understand what logarithms are and why they're used. So to review, exponentation is nothing but repeated multiplication. So let's say we're given 2 to the 5. Here, 2 is the base, meaning that's what we'll be multiplying. And we're going to multiply it by itself 5 times. That's what the exponent is for. So this is simply equal to, let's do this in a different color, equal to 2 times 2 times 2 times 2 times 2, which is just equal to 32. So that's really all exponentation is. It's a really simple topic. Let's try one more problem. So let's say we're given, let's just write down the old problem once. Okay, let's say we're given 3 to the 3. This will be 3 times 3 times 3, which is equal to 27. So this is all fine. We're given a base, right, 3, and we're given an exponent, 3. In both examples, it's the same way. And we're asked to find the output, which was 32 and 27. But what if we're given the base, right? Let's take this same problem, 3, and then we're given the exponent as a variable, x. And then the output is already given as 27. And now we need to find the variable. Well, what's the mathematical way of representing this? Well, that's where logarithms come into play. So logarithms are generally in the form log b of x equals y. And all the logarithm is doing, it's saying, what power do we have to raise b to, the base, and that power is y, in order to equal x, the output. So taking this same problem, we would represent this as 3 log 3, that's our base, right, in both cases, of 27, that's the output, equals x. And this is going to be our exponent output. So now let's put this into words. What power do we have to raise 3 to get 27? Well, we already answered this. So we know that 3 to the 3 is equal to 27, which means x equals 3. Now let's try a few practice problems in this way. So try to pause the video and try these problems on your own, and we'll come back and solve them. Assuming you've now solved these problems, let's evaluate them. So let's do it in this color. So in the first example, the base is 2, the output is 16. It's asking what power do we need to raise 2 to in order to obtain 16? Well, we know that 2 to the 4 is equal to 16, which means x is equal to 4. In the second example, what power do we have to raise 7 to obtain 343? Well, 7 to the 3 is equal to 343, so x is equal to 3. Now in the final example, what power do we need to raise 5 to in order to get 125? Well, 5 to the 2 we know is already 25, so we can try 5 to 3, which is 125, which means x equals 3 again. So that's just the basics of how to evaluate a logarithm, right? Now, let's practice putting a couple of exponential equations into logarithmic form and a couple of logarithmic equations into exponential form, just to really get the hang of solving. So let's choose an orange color. Okay, so your task here is going to be to evaluate the exponential equations into logarithmic equations and the logarithmic equations into exponential equations. So pause the video and try these. Assuming you've now finished, let's move on. So let's discuss the first problem. We'll do this in a nice green. So the first problem, 7 to the x equals 49. This would be log 7 to the 49 equals x, right? So what power do we raise 7 to get 49? And that's x. Now in the same way, this would be log 6 of 216 equals x, because we're raising 6 to the x to get 216. Now let's convert to logarithmic equations. So the first one, log 2 of 64 equals x. So we're raising 2 to the x and we're getting 64. So this is just written as 2 to the x equals 64. Now the second problem, we're raising 4 to the x to get 16. So we would write this as 4 to the x equals 16.